How to calculate the bearing capacity of soils. Soils are highly variable in their ability to bear weight. Failure to calculate the bearing capacity of the soil can lead to sinking foundations and buckled roads. It's also a factor in choosing heavy equipment for use where too much soil compaction can kill tree roots, or equipment can bog down. Engineers calculate the ultimate bearing capacity of a site's soil and then add a factor of safety. Still, things can go wrong. Shear failure of the ground occurs when there's too much weight on it, and the ground sinks under the load. That's what happens when your foot sinks into soft soil. When it happens to a building or a road, however, it's a huge problem. Engineers use several methods to test the ground for firmness, and they use formulas to calculate the size and depth of a foundation needed for a given weight on a given soil. The firmness of soil depends on its composition. It could be clay, sandy, or any mix of clay and sand. Clay has interlocking particles that resist shear up to a critical point, beyond which the clay will shear by deforming in a plastic flow. Soil almost always includes some water, which strongly resists compression. But the moisture might drain. That's one reason why sinkholes can form in sandy soils during drought conditions. Engineers use several methods to test the soil. The simplest is to push a probe into the ground, and measure the force needed to make it sink. This can be done with a handheld probe, or a larger version mounted on a tracked vehicle. For deeper measurements, core samples are taken and then tested under compression in a laboratory. These tests can simulate stresses in more than one axis. They can also test for permeability to moisture. Armed with the test results, engineers calculate how much load the soil can safely bear. Beginning with the weight required to shear the soil, they add a safety factor so the structure never applies enough weight to deform the soil. They can adjust the footprint and depth of a foundation to stay within that value. Alternatively, they can compress the soil to increase its strength. For instance, they might use a roller to compact loose fill material for a roadbed. Even when all the calculations are correct, problems can arise later. Change over time is difficult to estimate. That's why buildings that were fine when constructed can begin to settle over many years. Given enough time, even solid rock can deform and flow under the weight of mountains. Landslides are sudden, but entire hillsides can very gradually creep down, causing structures to fail. Washouts from flooding, or frost heaving in freezing weather can wreck roads.